Alright, this is lesson 41, Systems of Inequalities. We're going to do what we did yesterday, except that we're adding two graphs to what we're doing. And it's a system, so we have to make sure that our solution works, so whatever solution we pick. So here are the steps if you're on the video. Make sure each equation is in slope-intercept form. Plot one equation with a dotted or dashed line. Plot the second equation, same thing. This is what we did yesterday, but we only did one of them. And then, of course, the solutions include the most shaded region and the adjacent solid lines. We're going to talk about that, okay? Anyways, here's number one. Just watch right now numbers 1 and 2. So number 1, we have two equations up there, right? So if we have two equations up there, we have to graph both of them. So we have y is greater than or equal to negative 4x plus 3. So first thing we want to do is find the y-intercept there. So it's positive 3. I'm going to ignore that second equation and just go one at a time. So we're going to go positive 3, and the slope is negative 4. How do I make negative 4 a fraction? Over 1, right? And that's over positive 1. So I'm going to go down 4 and over 1 and plot a line. This is a solid line because, look, it includes the equal sign here. You see? Okay? And then we shade above or below on this one? Above, right? Because it's greater than. So we're going to just shade above like so. And we are done, okay, with that one. Then we remember that is there just one equation on this problem?
No, there's two.
There's two, so I have to go back to the second one. So we have our y-intercept here is negative 3, and our slope is 2 over 1, so I'm going to go up 2 over 1. We have a point at the same point there, up 2 over 1, up 2 over 1. And this one also is a solid line, so we're going to draw a solid line with arrows at the end. And this one says greater than or equal to also, so I'm going to shade it again, and it's going to have overlapping regions. The answer is where it's shaded the most, and the lines next to it. So if it's a solid line, so let's say this is region 1, right here, and this is sorry that looks really bad. 1, region 2, region 3, or region 4. Which one is overlapping the most? It's region 2. So any point that's in this area or that's on the line next to it would be included, okay? Because these are solid lines. That's number 1, okay? Number 2, let me do it one more time. We got y is greater than 1/3 x minus 2. First thing I want to do is go to negative 2 and draw my y-intercept here. I'm focusing on the first one, and then it's rise 1, run of 3. And I know this is going to have to be a dotted line, okay? So I'm going to plot the points with and then graph them with a dotted line because it doesn't include equal to, okay? And then this one says it's greater than, so I'm going to shade above it. So I'm going to take my side of my pencil and shade it like that, okay? How many equations are there now? 2, so I have to go back to the second one. Oop, went too faster, sorry. Second one has a y-intercept of 1, so I'm going right here. Rise of 4, 1, 2, 3, 4 over 1, 2, 3. Down 4 over 3. And I'm going to draw a dotted line again. Okay, arrows at the end. And this one is shaded also above, so I want to make sure that I shade above. And again, this one I'm noticing, I'm going to turn off the light so that you can see a little better in here. I'm noticing it's overlapping the most right here. And let's just say I were to name these regions. This is region 1, region 2, region 3, and region 4. Okay. Which one is overlapping the most this time? 1, right? And can I use any points that are on the line that are next to it?
Yeah.
No. Why can't I do it this time? Because these are dashed lines. You see this? Whenever it's a dashed line, we can't use the points on the line. Over here, do we have dashed lines or solid lines? Solid. So can we use the points here? Yeah. Okay, good. So that's numbers 1 and 2. So what I'd like you to do right now, well, first thing, do you have any questions on numbers 1 and 2? Yeah.
I didn't catch that last part for number 2. Why can't you use the points on the...
Because these are not included. These don't say equal to. You see how it doesn't include equal to?
Yeah.
So that means I couldn't use any of these points ever because it wouldn't make my equation true. We couldn't use the points. We have to assume we can't use these points because they won't make the equation balanced, or it won't be a solution to our system. Okay? Any other questions? Okay, good. So let's have, Friday, let's have one solid 2's about number 1, and then 2 solid 1's about number 2. Ready, set. Continuing on here, number 3. Okay? Let's do this one together. On this first equation, what is our y-intercept?
1. Positive 1.
Okay, positive 1. So I'm covering the second equation so we don't get confused. So we're going to plot 1. So why don't you guys write a graph on your paper? You're doing this together with me. Okay, continuing on, what is our slope then?
Down 2
Over which way 3? Negative 3?
Wait, no, positive.
But the denominator is always positive, so we're going to go down 2 and over 3. So you should go there. Excuse me. Okay, since we ran out of paper, we're going to go the opposite way too. And this is a dashed line. Why is it a dashed line?
It's not equal to.
Good. Where do I shade, above or below on this one?
Below.
Why?
Less than.
Good. Okay. Excellent. Keep going here. Let's look at this second equation now. What's the y-intercept of the second equation?
Negative 3.
Negative 3. What's our slope?
Negative 2 over 1.
Negative 2. No. We're not looking at number 4 yet. Okay. Again, what is our slope on the second equation?
Negative 3.
No. Negative 2 over 1, right? So we're going to draw a line. Is it going to be a dashed line or a solid line?
A dash.
Am I shading above or below?
Above.
Okay, good. Now looking up here, we have 4 regions. Turn to your neighbor, tell them what region the solution is in, or solutions are in. Okay? Go. What region are the solutions in? Okay? What do you think? Raise your hand with your answer. 1, 2, 3, or 4. Okay, good. The answer is 4. Now I got a question. What about the lines next to 4? Are those counted?
No.
No, why not?
Because they're dashed.
Good, because they're dashed. Excellent. Okay. Keep going here. Number 4 now. Number 4. I want you to work this one out by yourself. Ready, set, go. It look like this, right? Okay, I got a question for you. What region are the solutions in? 1, 2, 3, and 4. Show me with your fingers. 1, 2, 3, or 4. So 1, 2, 3, or 4. Show me with your fingers. Okay, answers up. Let me see. Okay, good. 2. 2 is the correct answer. Right? Because what about the lines next to 2? Are those answers also? Are the lines next to 2 solutions? Yes or no? Yep,
Yes.
that's right. Excellent. Okay, number 5. I'm going to hide 6. Just number 5. That's it. Go. This one you should have a y-intercept of 3, slope of negative 2 over 1, so you should have a graph looks like that. And it's solid. And it's shaded underneath, right? The other one's going to be, looks like that with shading underneath as well, but it's a dotted line. Okay, and of course we have our regions. What region are the answers in? 3, 4, 5. I give the answer. What region is it in? 3, right? Now I got a question for you. Is anything that is in this area a region on this line?
Yes.
What about on this line?
No.
No, why not?
Because it's dotted.
Because it's dotted. Does that make sense, everyone? Okay, so let's say I was going to pick the point here. Okay, would y'all agree that 1, negative 3 is in the region 3?
No.
Yeah, it's in there. You see 1. Here's the origin. 1, negative 3. You see? Okay. Okay, if I were to plug this into the original problem, look what happens. I'm going to plug it in. Y is less than or equal to negative 2x plus 3. Shh. I'm plugging in 1 and negative 3. Negative 2 times 1 is negative 2 plus 3 is 1. So, yeah, that works. That works for me. I'm going to do it again for the second equation. And I'm noticing, hey, look, it works again. It means it's supposed to be negative 1. That means both of these make sense, right? Is it true that negative 3 is less than or equal to is less than or equal to 1? Is that true? Yeah, is negative 3 less than negative 1? Yeah, so this is the solution. Now, what if I pick 0, 0? What if I pick this point here, 0, 0? Let's see if this works. If I plug in 0, 0 on this first one, you get 0 is less than or equal to 3. Is that true? Yeah, that's definitely true. Now let's put it on the second one. If I plug it in on the second one, is 0 less than negative 1? No. So is this true? So is this a possible solution to my system? No, it's not. Okay, so that's why this matters. Okay? All right, that concludes this lesson.